All right, our topic for lesson 4 is called angles. I'm going to write this up here. And in your notes, make sure you write down lesson 1-4 and write down the topic of angles. Now, before we actually get into the actual topic of angles, let's review just a few things here with the lessons that we've already had. In the following, it says, write a symbol to represent each type of the following. I want you to include this in your notes also. So make sure you've got 1, 2, 3, 4, 5 written down along with what it says there. Now, in the first one, it says segment MN. Now, how would I write this using proper notation or symbols? Well, I would write MN. Make a little better M there. So MN, capital letters. Now, for segment, it's just a straight line, no arrows. Point R. Now, there's not a symbol for point, so it would be just that, point R. Number 3, line ST. Capital letters. The only difference between the symbol for number 1 and number 3, arrows at the end. Now, number 4, ray AB. Now, the order of the letters makes a difference. So the ray, the first letter, is where it starts, and this ray would go through point B and keep on going. Now, the actual symbol always points to the right. And then finally, on number 5, ray BA. So the B has to go first through A, and then the symbol always points to the right. Now, I just want to show a picture of each of these. So segment MN would look like this. So M and N. And you could have those flip-flopped around. A point R would look like this. A line ST, so I have a line, and on that line I have 2 points, S and T, or T and S. Ray AB, the ray is going to start at A, it's going to go through point B, and keep on going, so something like that. And then finally, ray BA, starts at B, goes through A, so I'm going to have B and A, and I'm going to have the ray maybe going like that. You'd still write it like this, though. The symbol always points to the right. All right, let's get into angles. Now, I want you to make a sketch of the diagram that I have here. Now, in this diagram, I have what is shown as an angle. Now, let's take a look at what an angle really is. I have a point A, I have a point B, and I have a point C. Really, an angle, by definition, is 2 rays. Notice I have ray BA. So starting here, going through A, keeps on going. And then also I have a ray BC. So it starts at B, goes through C, keeps on going, right? So an angle is actually 2 rays. 2 rays that have a common vertex. Now, the vertex is where the 2 rays meet. Now, make sure you've written down what a vertex is. It's where the 2 rays join or where they meet. Now, when we write the notation for an angle, there's actually quite a few ways you could do that. We could write it, and notice the symbol here, which is angle. That's not a less than sign. A less than sign is kind of, it's not lying flat, whereas an angle symbol does lay flat. So there is a difference. Now, I could name this angle ABC. I could also name it angle CBA. What does make a difference is the vertex. The vertex has to be in the middle. So notice that my vertex is always in the middle. That is a requirement. Now, I also could throw a number in there and make a little shorter way for the notation. Just call this angle 1. Whatever the case is, an angle is actually the part that's opening up. So in other words, notice how far this angle is opening up. This angle might be maybe 45 degrees. Now, if I have another angle that opens up a little bit more, like this, maybe that angle is 60 degrees. Make sure that you understand that an angle is how far those rays are opening up. Okay, so that's the notation for an angle and what an angle actually is. Now, there's different types of angles, and I want you to make this bubble map. And in this bubble map, we're going to talk about the different types of angles. Now, there's actually 4 types of angles. We have acute angles, we have right angles, we have obtuse angles, and we have straight angles. Now, I'm going to start with a right angle. Now, a right angle is actually a perfect L shape. And when we write a perfect L shape, usually we put a little box in there, meaning we're telling that, hey, this is 90 degrees. Because sometimes you might have what looks like a perfect L shape, and you might measure it, and it may be 89 degrees or 91 degrees. Well, when you have that box in there, they're meaning that to be a right angle. So that perfect L shape is a right angle, meaning it's 90 degrees. Now, anything less, if that perfect L shape folds in a little bit more, that's acute, meaning it's less than 90. So any angle that's less than 90 is acute. So maybe this is 60 degrees. An obtuse angle is greater than 90. So maybe that perfect L shape opens up more than that L. Maybe this is 120 degrees. So anything bigger than 90 degrees is an obtuse angle. And finally, the 4th type of angle is a straight angle. A straight angle actually is a straight line. It's 180 degrees. Any straight line is what we refer to as a straight angle. Now, there's 2 postulates, and this is probably the most important part of this lesson. The 2 postulates, or actually this first postulate that I'm showing you here, and actually, let's see, let me look ahead here. We have some definitions, so actually you only have 1 postulate. The 1 postulate is called the angle addition postulate. Now, remember we've already had the segment addition postulate, which says that if I have a segment and I have 3 points on that segment, we say that AB, the distance from A to B, plus the distance from B to C equals what? The whole distance from A to C. That's the segment addition postulate, because it deals with a segment. Well, what do you think the angle addition postulate deals with? And if you said angles, that's correct. So the angle addition postulate says, and notice that I had to make those little lesson signs here. Really, they should look like this, but on the keyboard here at that time, I wasn't able to do that. But the angle addition postulate says the measure of angle AOB. So let's find AOB. So angle AOB is this part plus angle BOC, which is this part, add up. They add up to, guess what? What the segment addition postulate add up to? 1 part plus the other part added up to the whole thing. Well, this part plus this part add up to the whole thing of AOC, the whole angle. So in other words, this angle plus this angle add up to the whole thing. Maybe a numerical example would be if angle AOB is 40 degrees, and say BOC is 50 degrees, then they would add up to what? The whole thing, which is 90 degrees. And obviously that's not a good example because that's not a right angle. But you kind of get an idea. Maybe a better example would be, let's see, AOB, maybe, let's call it 20 degrees. And then BOC, maybe, let's leave it at 50 degrees. So what do the 2 add up to? The whole thing, which is 70 degrees. Now, down below here, really we have the same example, angle AOB, which might be 45 degrees, plus angle AOB, or BOC, excuse me. So maybe BOC is, and I'm going to change that here, say that's 40 degrees, we'll keep it simple here. So maybe this is 140 degrees. Well, what's 140 plus 40? They add up to a straight line. And you can see that these 2 angles are adding up to a straight line. Then sometimes that is just called the 180 degrees postulate. So the angle addition postulate says that one angle plus another angle add up to the whole angle. Now, congruent angles are angles that have the same measure. So if you take a look at this angle and this angle, they're both 40 degrees. Well, they're congruent. Now, what's congruent mean? It means they have the same measure. And then the symbol for congruent is that equal sign with a little squiggly line above it. Now, adjacent angles. So what you have in your notes so far on this slide is you have congruent angles. Now write down probably the little bit more complicated definition, which is called adjacent angles. Adjacent angles are angles that have a common vertex and a common side, but no common interior points. That's kind of a wordy definition. Let me give you an example of that. So make sure you have the definition first. Now, if I have, say I have an angle that looks like this, and let's call it AOC. And then I have another ray, which is going to give us actually quite a few different angles. So really, I have an angle AOC there. I have an angle AOD. I have an angle DOC. Okay, those are just some of the angles that I have. Now, adjacent angles are this. And I'm going to outline these. So say I have angle AOD, so angle AOD, and say I have angle DOC. I'm going to outline those, or highlight those. So angle AOD is this one, and angle DOC is this one. Now, which ray is double shaded? And you can see that the double shaded one is right in the middle. It's shared. It's right in between the two angles, isn't it? That would make these two angles adjacent. So if that double shaded or that common ray is in between the two angles, they are adjacent. Let's go over an example where two would not be adjacent. I'm going to make somewhat of the same type of figure. Maybe get different letters. So I'll have a D, point E, F, and we'll go G. Right now, let's take a look at angle DEG and angle FEG. Now the question is, let's see if these two angles are adjacent. So angle DEG is the whole thing, isn't it? Now angle FEG, now where's the double shaded ray? It's on the outside. So no, these are not adjacent. If I asked you to give me two adjacent angles, what would they be? How about angle DEF and angle FEG? Now in this case, I'm going to use different shades here. Angle DEF is right here in red. Angle FEG is here. Now where's the double shaded ray? It's in the middle. So yes, those are adjacent angles. So when the double shaded ray is, or in other words, the common side is inside or between the two rays, the two angles I should say, they're adjacent. So make sure you ask questions on that because adjacent angles probably is the harder one to keep separated. So our topic on lesson 1-4 was called angles.